I was asked to go through the technical issues that we face when working with green. The presentation runs around them, but it's more of from an architectural point of view, of course, because we're architects and we have a lot of consultants that work for us. So what we do at the Stefano Berri Architetti, what we do is that we like to say that we do houses for trees where human lives. So we try to embrace architecture from a holistic point of view. We try to build buildings where there is a space for nature and there is a space for humans. We often work with a very large number of consultants that actually make possible all the work that we do. So we don't pretend to work alone. We actually look at many things to render things possible. But why would you like to build a house for trees? I think that's the first question, and that's, I think, the head of the studio, the thing that underline why we do what we do. So as we all know, and this is everywhere, we're too many. We're consuming mostly everything, and over the past 50 years, we've done it in a way that is not sustainable. So what happens that in the 50s, we were 29% of the population was in urban surfaces. By 2050, we're going to be 78% of the population living in urban surfaces. What does that? This is the picture of today. This is what's going to happen in 2050. Most of urban population is going to be gathered in China, India, and Nigeria. So that is also making the world facing not only growth of population that is exponential, but also making us face another challenge, which is understanding how this 3% of the world surface, and this is referred to the surface that is above the level of the sea level, so dry surface. How can we render it sustainable? Well, because what's happening now is that 55% of the world inhabitants are in urban environments. We're consuming 70% of the world energy. We're producing 75% of the CO2 emissions. And worst of all, and what makes even more difficult it all is the fact that most of the economical push of the world is actually in urban environments. So this turns the city in actually something that is actually a resource. As with the way we see it, is the place where we actually have to start. So we can use them as an actual place where we can start healing the planet and turning the environment in a place where we can actually all coexist. So what we know and what we do, we don't simply use green as a decoration. We treat it as a being. We try to understand which is the potential, and we try to increase that potential. So what we do is that a mature tree planted on the ground can absorb that 0.4 tons of CO2 per year, can produce oxygen, and can actually gather water. So if we take, for example, the Central Park, it has 20,000 trees. The Bosco Verticale has 800 trees on the facade. And and we think on making a tower as tall as the high-rise towers that there are in New York. And we can't make an estimation of the amount of trees that can actually be on that tower. We can, by building only 15 high-rise buildings as tall as the ones that are in New York, you can actually have the same amount of trees as the ones that are in the Central Park, in proportion. So you don't really need to make a void as big as the Central Park to actually increase the green environment within the city. So what we have been working on for several years now is on a call for trying to bring people to think on ways to turn our urban environment into a green environment. So I think this is the example that we all know, and is from where everything started, actually. So what happened in the vertical forest? The vertical forest actually is a project where architects, engineers, an agronomist, a landscape architect, and many others came together to actually render this thing possible. It was a work of research, but most of all, it was we actually need to thank our client who actually thought that gave us the opportunity to actually do this thing, because the first reaction that we got from them were, "You're crazy." So we were speaking of putting trees on the facade, not bushes, not small plants, but actual trees. Bosco verticale host trees that go from ranges from 3 to 9 meters. So we're speaking of a structural effort and many other efforts to render it possible. The building is made of 2 towers, actually are 2 towers, one of 100 meters, the other one of 76 meters. Host 800 trees and a number of other shrubs and species that actually rendered the ecosystem sustainable, because the other thing was we had to find a way of rendering the whole system a sustainable system that could actually endure and actually last after a few years. And actually, well, until today, nothing has died. So the whole exercise from the architectural point of view was to find a balance in between the human environment, of course, and the natural environment, so the house for the tree, so to say. We had to understand which are the dimensions, the distances, the needed space that actually a tree needs to be on a built environment. So that made us come to these huge cantilevers that you see in Milan, that are actually the minimum distance that you can actually have from the trunk of the building, of the tree, to the facade of the building. So both of them can coexist, and we can actually guarantee that the tree is not going to be growing in an impossible way and can actually grow, and that the building is safe itself. So that all brought us to this section that I think all of you have seen. If not, here it is, which was the result of many studies where we had to understand things like how the building behaves when there's wind, because it's a 100 meters tall tower. What it could happen if the trunk breaks. How to deal with the watering system, from where to get the water, which is always an issue, and how to calculate the whole system to make it sustainable, to make it economically feasible, and to actually meet a budget, because as we all work with a budget, we are given a number and we need to stay within that number. So structure. This is a picture of the building when it was still under construction. The structure is actually cast in place, post-tension structure. It was calculated by Arup. And the fantastic thing of it is that it's as slender as it could possibly be. So all the pots that are actually placed on the edge of the cantilevers are actually not rendering the structure heavier, but is actually the opposite. Then there was another thing that we had to take under consideration during the project, which was the fact that both buildings are seated on top of the tunnel of the metro. So there were vibrations. There were other things to be taken under consideration while building up the whole system. In the end, the building is sitting on sort of a platform, then there are the parkings, and then finally there is the tree. Then finally there is the building. Then one final thing that we had to take under consideration is the fact that Milan is sitting on water. So that was actually an opportunity, and then I'll explain you why, but this was actually a positive thing. So we get to the building itself, the facade. The facade is made by trees. So in here, the exercise was to understand which kind of tree, in which position, how it's going to be planted, the kind of the soil that was going to be used, the fact that we had to use lightened soils not to render it more heavy on the structure. Then there were effects like part of the facade is facing north, so in there the trees that were used are trees that are evergreen. That are losing the leaves during winter. On south, actually, are evergreen trees, because in there there is need for sun protection throughout the whole year. So also the building itself was thought as a tree, I would say, sort of an intelligent thing that throughout the whole seasons, all the 4 seasons, can provide the building with sun shading or sun filtering, so it can actually react to the external environment. Then there is the fact of the wind. I was very young, but there was a test made in Florida on a wind tunnel to understand few things about the tree, which are how the tree behaves when there is wind, which is the kind of trunk, the shape of the trunk that you have to have, the amount of, if the trunk has to be tall, small, fat, not, because that has an impact on the behavior of the tree when there are strong winds. Then, of course, there was the fact of how to bind those elements that were 9 meters tall to the structure of the building, and how to actually prevent it for, if the trunk breaks, for it to not to be fall, and other elements. So, and as I said before, there was also a study of how this building behaved throughout the whole seasons, and as above you can see on the slide, how the building was in 2014 when it was finished, and how it was in October 2 years ago. As you can see, the nature is growing, still developing, and is still, we haven't seen one tree that has that so far. So how did we manage to put all those trees above? First, they were bred on air pots for nearly 2 years, so they are prepared to live on special conditions. Then, of course, all these trees were chosen one by one by our agronomist, her name is Laura Gatti, and choosing, it was made according to the size of the trunk, the height of the trunks, the leaves, and many other elements that, according to her studies, render them suitable for living in this kind of environment. Because, of course, after there was made a wind tunnel trial, then she also made some fluid studies of the wind that were then applied to the trees itself, to the structure of the tree, to understand which is the correct structure of the tree for it to then be chosen and brought to the building itself. So this is one video of the day in which they started putting up the trees on the facade. And this is how the trees are actually binded. So from the wind tunnel, we learn the shape, the size, but we also learn how to grab them to the structure, because of course there are many different aspects that there were. So trees that are from 6 to 9 meters are actually bind to the main structure with cages, because we could not rely on the roots of the tree for binding them correctly to the structure. The mid-sized trees are actually tied to the structure with strings. So, because we knew that the trees, the roots in time were going to be strong enough to actually hold the tree to the structure. So this is actually a picture of one of a 9 meters tree put it to the building, and how they are actually binded to the structure with strings and with metal elements, so for it not to fall. Then another thing that is quite present on the facade, and everybody asks, is what are those metal elements that come from the ceiling of one terrace to the other? Those are actually needed for if in case the tree trunk breaks, it won't fall to the ground, because we're speaking of a tree trunk falling 50 meters, 70 meters, that's quite easy. So it's a safety thing. Then, as I said, Milan is sitting of water. That actually gave us the resource for the water that is needed for the irrigation of the whole system. So what happens in Milan is that we gather water from the underground, is pumped to the roof, and then by gravity falls throughout the whole irrigation system, which is a drop system that works throughout the whole year. It's continuous, it's not stopping. And then, of course, together with the rainwater, gather all together again and put to the sewage. This because in Milan, part of the soil water is also used as a potable water. So we cannot put, again, the water that comes from the trees into it's forbidden by law. So that's why the water that is gathered after is going to the sewage. So there is one of the points in which the water is taken out for potable water is quite close, so it's an area where it's not allowed for you to put the water again in the soil. So the result is this. It's a building that works pretty much like a tree itself. That is in a way creating this kind of atmosphere. It's a place where there is living nature. There are animals. There are nearly 20,000 birds living in the building nowadays. One interesting thing is that at some point there was some kind of imbalance in the ecosystem that was created, and some bugs and elements where we had to bring it to the building to then balance the whole system again. And of course, then there is the question of maintenance, which is the big question always. Because there were many moments it was said maintenance is quite expensive. Fact is, yeah, it's expensive, but it is expensive because it's a luxury building. We're speaking of a building that has a 24-hour doorman, spa, gym, and many other things that render it expensive. The greenery, the maintenance of the greenery in the building is only 10% of that cost, so it's not that much. And also, when trees, bushes, and all the species are chosen, the idea is to be sure that those species are first suitable to live and to survive in the environment, that are sustainable, which means that they are not consuming too much water. They are not they are behaving correctly throughout the seasons, that from the maintenance point of view, they are not requiring too much maintenance. The idea is that in time, the need for maintenance is reduced, not increased. So all the reasoning that there is behind for this work is to to build something that in time is independent or is in need of the less maintenance as possible. So this is the building nowadays, and this is some of the advantages of doing something like this. You have a building that absorbs CO2, produces O2, reduces the energy consumption of the building, reduces the heat island effect, multiplies biodiversity, and above all, it's proven that people that is living close to green environments are actually healthier. So what you have are the benefits of living close to nature within a urban environment. So we get to the point in which what happened next. What happened next is that we are nowadays having projects all around the world. The approach is pretty much always the same. We take a look at the client request, the environment, the climate conditions, the species that are native, the species that can be introduced, the species that can be reintroduced in the environment. And with all of that, we shape buildings that are actually capable of hosting nature. So these are not all the projects, but quite a few projects that we have ongoing now in the studio. Most of them, or a few of them, are actually in China, which is an interesting place because it's starting from zero. So in there, from what we've been told, actually you don't only go there and pick the trees that then are going to be in the building, but you need to tell them how to do them. We have to kind of teach them how to grow the tree, how to breed the tree, how to actually prepare the whole technology to then make it possible for it to be built. The examples that are brought today, of course, are examples that are here in Europe, which are quite different among them. So one of them is the Lausanne Tower. This is a competition that we won. It should be built one day. This building has a number of trees. The fact is that in here the request from the competition was to have large views. We had to create houses that had to look over the city with no barriers. So that brought us to think on a completely different way of actually holding the tree or creating that space for them. These are the species that were chosen, which are all from the area. And then here is the structure. In here is completely different from Bosco. This is a prefabricated structure made in metal, where the tree is not actually making a handrail or is not popping up, but it's actually on the level of the ground level, so you actually get to see the whole element. And above all, it's a building that is much more transparent than Bosco. The need for sun in Lausanne is much more. It's much more big than the one that we have in Milan, where during winter it's very cold, but during summer it's very hot. So then there has to be a balance. In Lausanne is quite different. So then we have Utrecht, Wonderwoods. This building hosts nearly 1 hectare of a forest on the facade in comparison. So in here, what happened is that the whole study for the green environment was made to actually introduce species that weren't from the area, native, but that weren't there anymore. So part of the study was came into how to bring back the species that were there that were not there anymore, and do it through the building itself. Then on the development of the project, there are some other aspects, like they are studying a way of reducing the amount of mosquitoes that there are in the city during summer, using some other natural elements. So here they're actually doing a big effort to use nature to enrich the ecosystem. In here, the structure that actually holds the tree is a pot that then turns into a sort of a storage space. And that actually renders possible the fact that all the green that you have, instead of in Bosco you have one thing that is as tall as me, well, my head would be outside, for to guarantee that there is the enough amount of soil and subtractant for the tree to live. So in here what it was made is that all that height that is actually needed was brought to the floor below, so you can actually have the feeling of the greenery that is right in front of you, but at the correct height, which is the height of you when you are standing. You can look above, not from down below. So here's a section. Normally, what we try to think is that for tree, 80 to 1 meter of soil is needed, more or less. And what is made, or what we do, is that the details are adapted studies of the local rules and regulations. So nothing that we do is actually invented. We actually study the local law and make a reference to them and then adapt it to our buildings. And this is made for all the buildings. It was even made for Bosco. Every country has its own laws, and we have to make reference to them, so this is the way that things are made. Then I think this is one of the most interesting examples that we have, and it's because it's social housing. So we came from Bosco to one thing that is, it has to be way more sustainable from the economical point of view. So in here, the whole study was made to understand how this whole structure could be actually cheaper, much more cheaper. So of course, the typologies of apartments were one, and it's all very modular, but the most interesting thing was the facade, how to actually bring trees into a facade that has to cost way more than the one that we did with Bosco. So in here what we have is a series of pots, precast pots, that are placed on top of a concrete structure that is being built as we speak. That, according to its dimension, shape, size, and position on the building, render possible different sizes of trees, bushes, and smaller green elements. This is are the species, part of them, of course, of the species that are going to be placed on the facade. And this is the difference. So Bosco costed $2,700 per square meter. Trudeau Tower has to cost $1,500 per square meter. So the difference is made through the study of a prefabrication system that actually render possible this difference. Bosco, of course, had a completely different target when it was assigned to us. They were asking for a luxury building, so the target was different. This one is another story. So part of all the effort that we've made is also to take all that we learned from Bosco, all that we know from it nowadays, because we're still monitoring the whole building, the facade, and the green environment, and use all that information into other projects to then see how we can improve it, render it more sustainable, cheaper, and easier to be built. Then finally, there is Palazzo Verde, which is the building that we are doing here in Belgium. In here, this building actually, seeing all the ones that I showed you before, is different. But this is what happens when you do architecture. Every project is a new project. Every client is a new client. And every environment is a completely different environment. In here, what happened is that the request was for a low building. It was for, the budget was quite different, the target also. And we had to, at some point this building actually had trees on the facade. But then understanding the maximum height of the building, the maximum body of the building, the maximum of everything that we could actually have in here, we came to the conclusion that we had to look at it in another way. So the other way was the body of the building, how we could actually shape the body of this building for it to be able to host trees and to create large green environment, a large green space. So from an individual tree, we went, or an individual green environment, which is not as such, because one thing that I forgot to tell you before is that in Bosco and in all other projects that we do, the maintenance of the green system is not made individually. It's not trusted to the single tenant. It's actually something that is seen as a common good. So everything is, the maintenance is trusted to everybody. Everybody simply pays the fee that is to be paid, and is made globally. So it's not like you can go outside and if you decide you can cut your tree and then go away. It's an ecosystem, and it's a very delicate system. So it's very important that what we thought is that in this kind of buildings, the green sphere is actually a common good and is treated as such. So here what we did was we created nearly 700 square meters of green space, green gardens, which we call the unfolding forest. These gardens are placed on the roof terraces of the building on the 7th floor, 6th floor, and 4th floor. They are all connected to and accessible to all the tenants of the building. So everybody can move and have direct access to these terraces. This is a view of the terrace at the 4th floor. And this is where things got actually very interesting, because of we, of course, made work with our agronomists to understand which were the species that we would like to place in the building according to all our ideas. And then when we face the client and the people that is actually going to realize the green roof, we discovered that in here there is actually a list of a blacklist for trees, and we had quite a few of them on our list. So then we had to adapt our ideas, find another trees that could actually be suitable for it, and then finally we came to the 86 trees that are going to be in the Antwerp Palazzo Verde rooftops. So on the 4th floor there are nearly 350 square meters of green roof. On the 6th floor, if I don't remember wrong, are around 250, and the difference to that, to the 700 that I said before, are on the 7th floor. Then there are the private terraces, which is the moment in which the building again changes its shape, the shape to grant space to a green environment. So the steps that are created, that you see on the facade, are actually spaces where you can actually, we are actually thinking of having very big trees that are accessible to, I think are 7 apartments that are directly connected to private terraces. In here again, the green is not thought as individual good, it's actually a common good. So in theory, if you just look at it from a legal point of view, you own the terrace, but you don't own the trees. The trees are a common good to all the owners of the building. So this is the a view of one of the private terraces. And to finish, this is, I think maybe you have seen it, is a promotional video made by our client where you can see how the whole building works. This is a view of how we actually imagine the roof terraces to be, and how the whole building is actually enjoying the fact of being close to a green environment, quite wide open, and that actually grounds you, the feeling of being in a countryside environment while you're actually inside the city. And this is us.